Hello guys, today we are going to take another look at the Fendt 939. We still need to fix our steering issue, so we'll get that sorted today. And as well as that, we had a problem with these LEDs. Well, actually it seems like any of the LEDs that are connected to the I/O expander chip, they seem to be slightly dim, they're not going fully off. So we'll take it apart, hook it up to the oscilloscope and can we see what's happening. Why are they not going fully off? So just one thing to point out that I realised since the last video, the pins up here, the ones that are not really working for us, they're being sourced from the PCF 8574 chip, and I've discovered since that there's only one way you can wire it, and it happens to be this way. You have to wire the LEDs high and then use the chip to sync the current. So you can't try to source the current from the chip because it can only supply about 100 microamps as a supplying power source, but it can sync 20 milliamps. So you have to wire one side of your LED to the positive 5V rail, and the ground side goes to the PCF 8574 chip. You can't put the ground side to ground and the high side to the PCF chip because it won't supply enough current to drive your LEDs. They won't light up, they'll be too dim. So that's just something to be aware of if you're wiring up one of these boards in the future. But the first thing I'm going to start with today is the steering. So you've seen in the last video there's something wrong with the pins that hold it together. So I'm going to try and take them apart and replace them with a couple of little bolts and tighten everything up, and hopefully that'll solve the problem. Alright, well here's our axle, and you can see we have this big gap on one side. So it should be nice and tight like that, but you have this big gap here because these pins aren't as tight as it should be. Those two little pins in there, so they're not as tight as it should be. That's this big gap and lets this float around. So that's no good. That'll mean our steering's all out of whack. So what I'm going to try and do is drill out these two little holes here, tap it for two little bolts and try and tighten it all up. So not sure if it's going to work, but as it stands this isn't really great, so we have to do something about it. Alright, well here's our little fix. I basically just drilled out the two little studs, or I don't know what you'd call them, little pressed pins that was in there. And well, first actually I got the drill for the tap, and I drilled straight through both pins. Then I got a bigger drill bit, drilled the heads off the two pins. So then when I took it apart, I already had the holes drilled pretty perfectly through the lower plate here. So then after I cleaned off the top of this lower plate, I tapped through to an M2 bolt pattern. So I have two M2 bolts then screwed in there. But when I drilled out the two pins out of here, you're left with quite a large hole there. So I put this little bit of plastic, you can see it reflecting there, just a little bit of scrap packaging plastic, nothing special. Just drilled two holes in that and used it as a little thing to tighten it. The only thing I'll say is, if you're doing something like this, this is just aluminium, so you know, don't tighten the screws crazy tight or you'll just pull the threads clean off. So it's never going to be under any real load, it's just carrying the weight of the model. So tight's tight, like don't get too carried away with yourself tightening up the bolts. So that seems fine. I don't think the important thing is that this rack here doesn't come off the gear, so that's not going to happen. Like it's fairly solid. Like the wheels will still float around like mad, like, but you know, there's nothing you can do about that. That's to do with the axle there and how the plastic is sitting on the axle. But the important thing is that the rack here isn't going to come off the gear, so your servo won't be misaligned. Once you put this back together, it should always be in the right place here. So next we need to sort out our LED issue. Alright, here's the cab apart. It might be a little difficult to see the problem. There's a little flicker in the LEDs there, I think you can see it. So it's a little bit more obvious in the dark, but basically that's the problem we have. We have our positive connection here, I think, and that would be VCC coming from the control board, and then we have our ground connection, which is going to our PCF 8574 chip, and so that's going to sync the current through that chip when you connect it to ground. Well, it goes through the resistor on this little board here, but for some reason that's flickering, so we want to see, is there noise on the line or is there some sort of flickering? So we're going to hook it up to the oscilloscope and see what happens. Okay, so I have connection to ground. The first line I'm going to probe is the yellow wire, and the second one is going to be the black wire here, and we'll see is there some noise on those lines. So I'll switch you up to the oscilloscope now. Okay, well, first let's probe the yellow wire, which should be our VCC pin. So that looks fairly solid. We're getting around about 3 volts. That's probably right. Battery is not fully charged, so our regulator is only regulating to about 3 volts rather than 3.3. It's probably nothing too strange there, I wouldn't think. So next let's probe the pin that's going through the PCF 8574 chip, and there is our problem. That's actually, it doesn't look like noise, it looks like the line is switching for some reason. So basically we have a 3 volt drop, so the chip is basically switching that output off for some reason. And maybe if we go out, so you can see it's just pulsing away there the whole time, switching it off. Don't know what the reason for that is. But let me put the pin on high and see what the pin looks like then. When the pin is switched, we don't seem to have this problem. Which probably makes sense because it was trying to switch it low, so it's probably still trying to switch it low. So I need to figure out where that switch to low is coming from, why it's going low. But at least we've figured out what our problem is. Okay, well, the way I narrowed this down to what the problem was, I went through the code and I commented out all the lines that called the PCF chip. So that was your loader, the drive line, the lights. So went through them one by one, knocking them off until the problem disappeared. And as you can see now, there is no flash in there now, it's fully off. And what I basically narrowed it down to was the code that we use to communicate with the chip is an I2C code, and basically there's 3 inputs. There's the address of the chip we're talking to, then there's some register address is what it's called in the code or in the library. I have no idea what it is. Like I've said before, I don't have a clue about programming. I'm just kind of get away with mixing together bits of examples. So obviously I took that from the example. I don't know what the register thing is. I still don't know what it is. But basically, because I seen this problem, it going down, the register, by the way, was set to something like 02, so most of the byte was set to 0. So I thought, well, I wonder, is this thing setting all the outputs except for bit 2 to 0? And then I thought, I wonder what would happen if I just deleted that. So I deleted that out of it. So all I had then was write the address of the chip that we're using, because we have 2 chips in this, and the data, and I got kind of lucky. It's working now. There's I can turn on and off the lights and there's no problem there, and our loader code still works. So like I say, I haven't a clue what that register thing was, but it seems to have worked, so I'm not going to delve much deeper into it. There's a problem with the rear lights, but they're using the other chip, so I presume all I'm going to have to do is go back and do the same thing for the PCF1 code, and then that should solve that problem. Alright, well that's about half an hour spent going through the whole library, deleting that 0x02 pieces out of the I2C code, but it looks like that has solved the problem. You'll see all our rear lights are perfectly off there, not a problem. We don't have any flicker on these lights either, so I would consider that a success. So turn on our lights though. You can see that one light is coming out bright like we'd expect, but the other guy is fairly dim. So there's something wrong on this tail light. But if we put our full beams on, there they're on. But also we've figured out before that that wasn't bright enough, so I'm going to have to do something about that. So in the next video what I'm going to do is sort out this tail light and sort out those lights, make them a bit brighter. So this is basically, we're going through the kind of problems you might encounter if you try to make one of these yourself. This is the kind of stuff that can happen. You get it all together and then there's a couple of little problems that you need to just iron out. But like you've seen, it's not too difficult if you go about it in a kind of methodical way. If you go through it properly, it kind of works out for you in the end. So if you liked that video, make sure and hit the thumbs up, and if you have any comments or suggestions, let me know below the video. And I think that's it, so thanks very much for watching.